Welcome to the EU Energy Projects podcast, a podcast series from Enlit and friends, focusing on the clean energy transition for the European Union and the EU Commission-funded energy projects that will help us achieve it. My name is Areti Ntaradimou. I am the editor of the EU Energy Projects podcast and your host. Today, we're diving into one of the most transformative aspects of Europe's digital energy transition, data spaces. As renewables, prosumers, and smart grids reshape the energy landscape, seamless and secure data exchange has become vital for coordination, innovation, and trust across Europe's energy systems. Our guest today is Georg Hartner, representing the INSIEME project, a major EU initiative working to connect and streamline national and regional data systems into a common European energy data space, or SEEDS. Together, we shall explore how INSIEME is addressing data integration challenges, the implications of the EU Commission's regulations, and how Europe's approach compares to data governance models in other parts of the world. Georg, thank you very much for being here with me today. And could you start by giving our listeners a brief overview of what the INSIEME project is and how it fits into the broader context of Europe's energy transition?
Thanks a lot, Areti, for having us and for giving us the opportunity to present our project here. Project INSIEME is a Digital Europe action under the custody of DG Connect, to establish and deploy a common European energy data space by the sector for the sector. And it combines the forces of 54 key European partners, very significant, the most pragmatic TSOs and DSOs, solution providers from most member states, flexibility service providers, market platforms, and advanced digital actors in the energy space. We are piloting together solutions for the highest priority twin transition challenges for the final operationalization of the SEEDS with a target date of 2030. Our project is running from April the 1st, 2025 up until 2028. What we are trying to tackle with the Common European Energy Data Space is the problem that many actors in our sector have. Many of them are complaining that data integration is one of the biggest cost drivers that they have. Many of them all too often just can build solutions for one member state, and then it's very expensive for them to scale their solutions to other member states. This has been addressed in so many reports and in so many complaints, and we see a key mission of the Common European Energy Data Space to provide a solution for that matter, make it a matter of minutes, allowing them to take data integration for granted, which will boost innovation and the scalability of the business models of the users and participates in the seed.
Georg, that makes total sense, and it's actually very much in compliance with the ideas of the European Commission about competitiveness, and especially competitiveness against countries like China, like the United States, etc., that are bigger markets sometimes and maybe a little bit more progressed than us in some sectors. Now, the project is a very big one. It brings together over 50 partners across 16 countries. So it is in a unique position to see what is happening throughout the entire continent in EU states, see the pluses, the issues that are caused and everything. How do you coordinate such a large consortium while ensuring interoperability between existing national data systems? It is really huge.
Thanks a lot, Areti. Yes, it is a very big project with 54 partners and spread across so many different countries. The secret behind how do we get people engaged and how do we ensure interoperability of the solutions that are deployed within the project, ensuring that they can be deployed across all member states, is also the mission statement of INSIEME. INSIEME is the Italian word for together. So we are subsuming a lot of players that, due to the regulatory and legislative demands that are coming in with recent European developments, all of them have to do challenging but very similar tasks. And what INSIEME provides here is a platform for them to work together and doing things in a standardized way, aligning before they put things into action just within the scope of the national nutshells, and allow them to learn from each other. And by doing so, we could create a very engaging environment for them. And up until now, project is now 7 months old, we could keep and increase that momentum. And it's really tangible that we as a group, as a team, have turned from being a project into more like being a movement.
Hello everyone, Areti here. I would like to personally invite you to discover the EU Project Zone at Enlit Europe 2025 in Bilbao. Our event takes place from the 18th to the 20th of November. Come say hi to me at the EU Project Zone. Since we're talking about a movement, let's explain a little bit what this movement is about, because I've personally, in the past, made the mistake of mentioning data centers and actually meaning data spaces. And I was corrected by a policy officer on DigiConnect, thankfully. But I would like to ask you at this point, if you could explain a little bit what an energy data space is in practice, given also the fact that the European Commission's initiative to establish sectoral data spaces, including one for energy, is very central to the EU's data strategy.
Back in 2020, in the Europeans' strategy for data and also in the Data Act, the term data space was coined, but at least to our view, not satisfactorily defined, which is a risk and which has led to a lot of confusion in the beginning, but it also left a lot of leewards for all the sectors to define and interpret these data spaces in a way that makes most sense for the respective sector. And this is also what we are doing. And up until now, I would like to explain a little bit what we are doing very concretely in this project to give you a better impression of what a data space can do to this sector. As I've stated in the previous question, we are featuring deployment in 16 member states, and we are doing this in 7 basic categories. One is energy efficiency and flexibility management, providing and linking with the Common European Reference Framework for Energy Savings Applications and the Eclipse project. So one of our partners, ETRA from Spain, are managing this. So the linkage with the Eclipse initiative is very important for us, as well as providing a common European interface to prices, so to energy prices and grid tariffs, so that each European citizen with his or her solution can at any time predict what he's going to pay per kilowatt hour towards the grid, towards the supplier in the respective 15 minutes. This is very important to allow for what we call implicit flexibility solutions, so for solutions that react to prices. And the second thing is the big collection of energy sharing solutions, energy communities, collective self-consumption. In many member states, first and foremost, in Austria, we see an emerging economy based on these structures. In Austria, we have more than 7,000 active energy communities, and I think up until now, over 100,000 Austrian citizens being part of at least one energy community. We see similar developments in Spain, also in France and in Italy, also in Portugal. And what INSIEME does for these solution providers is they are sitting together and they are creating a write once, run anywhere layer based on the data space that allows them to put their solutions on top of the Common European Energy Data Space and offer these community services, not just in Austria, but also in all the other markets without having to change their solutions, which helps them to scale. They've learned, they've developed specific capabilities, and up until now, they are locked into a very small market. The third class of deployments that we do, led by Enedis, so French DSO Enedis, is grid flexibility services. We are tackling together the topic of standardization and providing efficient solutions for grid edge connectivity to realize flexible connection agreements. So a very important instrument for alleviating congestions and better utilizing our grid and better utilizing capacities. One very placative deployment that we do there is a globally acting office furniture company in Austria. They've put on their rooftops a 3 megawatt solar PV plant. They are only allowed at the moment to inject 250 kW. And the reason for this is that close to the rooftop solar PV plant, there is a water power plant. In between, there is an earth cable, which is the congested network element. And as of now, and you find that problem everywhere across Europe, there's no communication between the generators, the critical network element, and the DSO. And currently, there is a lot of emissions-free, cost-free, renewable electricity that needs to be curtailed because of this lack of communication. This is relevant for medium voltage, also for low voltage. There we provide a lot of solutions. Also, the integration of balancing and local services markets, flexibility, information systems. All of these systems are being built through the implementation of the network code on demand response and other regulations. We are providing a common European interface for these services by also providing a platform for system operators to team up and make their systems more accessible and more scalable across Europe. We have electromobility task where we tackle both residential smart charging and electric heavy-duty vehicles. Here, it's important for charge point operators to know where they can reliably put their charging stations, which complies very much with the implications that come from the European Commission's Grid Action Plan 6A, which requires distribution system operators to publish their grid capacity maps. And within the scope of INSIEME, we are standardizing that information to make it available in a machine-readable way for other actors to use that in their planning and to develop their business models. With Volvo Technology and Renault, we are working on data exchange between electric heavy-duty vehicle fleet management systems and charge point operators. The problem there is that currently heavy-duty vehicle operators have big problems planning their routes effectively, because currently charge point operators just publish their peak charge capacity and not the forecast of the actual charge capacity at the point in time when an electric heavy-duty truck wants to charge. This is a big problem because it leads to a lot of penalties and a lot of delays for these stakeholders. And it is one of the biggest blocker in the development of the electrification of electric heavy-duty vehicles. We have tasks on very smart forecasting for renewables, like bigger plants, and we have a task dedicated for networks and integration planning, so machine learning and AI-based smart solutions and digital twin solutions, here mainly also run by Enlit AI and Cuerva Adayon from Spain. And this is a very bleeding edge avant-garde task. And with our last deployment task, smart sector integration, particularly with a focus on Denmark, we're working on the integration of different energy vectors, electricity, gas, heat, cooling, water, into a common usable data infrastructure. So all in all, we want to make it a matter of minutes for solution providers to integrate into digital participative opportunities that come with a transformed system. And we want to make it as easy as possible for active European customers to benefit from these solutions.
Georg, what specific regulatory or policy frameworks from the EU are guiding INSIEME's work? For example, I would assume the Data Act?
Yes, of course, there's a lot, basically. So we have transversally relevant regulation and legislation that is important. So the Data Act, the AI Act, the Data Governance Act, the Free Flow of Data regulation. We also see pattern acts from other sectors. So the Implementation Act for the health data space as one example. And then, so these are, I would say, the constraints that we need to comply, higher level regulation. And what is very, very important and what we are very much aligned with is upcoming European legislation, like the upcoming network code on demand response, the implementing regulations for data interoperability in demand response, the electricity market redesign, and everything that comes with it. So these pieces of regulation that are built for flexibilizing our systems are implying the creation and deployment of digital solutions. And these are the things that we are following and aligning with. And if these initiatives are upcoming, the team does everything to feed back the findings that we do in our projects to improve these upcoming regulations.
I want to circulate back to SEEDS, or Common European Energy Data Spaces. And I want to ask, how does INSIEME contribute to the creation of one? And what makes this federation architecture approach particularly important?
Yeah, particularly in our sector, it's common sense and it's quite clear that the European level cannot interfere with how energy data management is being done in member states. It's a matter of subsidiarity. It's a matter of ownership structures, and it's also a matter of cost efficiency and making use of all the structures, organizations, and people that have evolved over the last years. As an example, in Austria, they started the Austrian Energy Data Space, or Austrian Energy Market Communication, EDA, in 2012, showing all the elements that you would now expect from a data space. And we see similar developments in Spain with DataDis, also a very remarkable service. Then also what Danish DSOs and TSO have built in Denmark. So these developments are existing. There's services already depending on these structures, and we need to do everything to link and leverage these structures, these systems, these services into a common European experience to ensure the support, to ensure a good participation, and rather a good service level at the European end. That is why I think not just in our project, but in a wider audience, there is a big consensus to go for a federated architecture in the seats.
Let's move a little bit to the pilot cases, because this is where the major work is done when it comes to try to apply it in actual cases. So could you please describe in a few words a few of the pilot use cases that are being developed under INSIEME? For example, flexibility or electromobility, etc.
Yeah, one example would be making available prices, supply prices, and grid tariffs. So you've got different tariff schemes for supplies, dynamic or time of use tariffs, fixed tariffs, then dual tariffs. And the big challenge here is to collect the data for supply tariffs and also to make available data on dynamic grid tariffs as they emerge, and have a common European point of reference to download them. So here our focus is more on data collection, more on business analysis, describing how these data can be made available, and not so much on the technical end. Whereas if we talk about flexible connection agreements, like in the example that I've shown before, it's very much about how do we learn to communicate with final customers, we as connecting distribution system operators. If you say, for a flexible connection agreement, you need to tell people that they have a higher allowance to inject now or a lower allowance, and you need to be able to rely on the fact that they actually receive that data. And we also need to employ fail-safe strategies if something doesn't work. Then a big gap in overall digital infrastructure in our sector is that there is no strategy at the moment to reliably identify and authenticate grid edge customers across borders, but also across different digital platforms. It's very, very important to make use of what's being done in other sectors, with the example of eIDAS, so electronic identification and authentication services. As so often, this problem has been addressed in different initiatives at the European level in a very good way. And here we are trying to connect and employ these structures into an overall identification authentication management infrastructure that works not just for the grid edge, but for the data space as a whole. And if we talk about flexibility management, there is a very important finding, namely, as in INSIEME, we would like to employ information model standards, data exchange standards. We are always trying to find and adopt international European standards out of the IEC family of standards. There we quite quickly came to the finding that there is no standard available that fully covers markets and the needs of interconnecting grid edge devices with system operators and service providers. And what we are doing in these cases is we combine the forces of our different pilots. We link into standards defining bodies, in this case, IEC TC57 Working Group 21, which are underway to create a standard compliant with the necessities of a flexibilized system as it's going to be ready with the implementation of a network code. Our colleagues there are under a big time pressure because when the network code comes into force, we will have 6 months until implementation works will start. And especially information model and data exchange standards should be available before implementation works begin for this important structure.
I was wondering a little bit about the challenges that you also must have faced. I have discussed with plenty of projects, actually also projects that have pilots in various European countries, but 16 is among the top, let's say. They are a lot of countries. So I was wondering, what would be the main challenges, either technical or governance related, in linking different national energy data platforms across Europe? Also because there are different rules and regulations per country, there is a different integration into the system of the country. There are countries in Europe that haven't even deployed fully smart meters, for example. So I was wondering about this.
Yeah, here we are making use of the patterns and of the findings that we generated in the previous project EDI, European Distributed Data Infrastructure for Energy. So one very big problem that we face is this diversity, as you say, in the implementation of European requirements. And we strongly believe that this comes from the fact that European legislation can just give 3, 4, 5 sentences to express what needs to be done. But then there is a big lack of guidance for the implementation. And if we just look at the access to smart metering data or metering and consumption data, in Austria, we have a highly decentralized environment, a generic consent management process where you get standardized access and you can access via your DSO portal, you can give the consent there, and it works across the member states in a very consistent way. Other member states have gone for different solutions. So, for example, Spain has put up DataDis as a consent broker to address this requirement. Enlit did their Data Connect Hub in Energinet in Denmark, have been putting up the Overblick service for exactly the same purpose. All of this is following a different architecture, different processes, and different data formats, and also different granularity often, and different times for when certain data becomes available. So what the pattern that we played through in EDI and that we are extending heavily in INSIEME is giving people one standardized process, one standardized pivotal data format, integrating these formats and processes to give the respective digital solution one environment. Another technical challenge that we have is not just between member states, but also for especially the integration of real-time data and smart meter interfaces. You have situations where it's very hard to get connected to your smart meter for services that require more advanced data integration than what you get through the normal smart meter chains, normal 15 minutes values. A good example here is what Rome DSO Areti does together with engineering. So in a more than 2,000-year-old city, they cannot just put a smart meter adapter or a digital customer interface on the smart meter because there's sellers There's probably a lack of power supply, probably a lack of Wi-Fi connection. And what they did to achieve this connectivity is, in Italy in general, they are writing crucial values to the in-house power line communication, where you can get it everywhere behind the connection and make it available where you need it. And also here on that end, you see that the diversity in implementation of European requirements is very big. However, the pattern that we've demonstrated in EDI also works there. However, they, especially Areti and engineering, they are very committed to providing standardized interfaces to allow them to work their way in the back. And here, key for getting around these problems is really cooperation and alignment on the standards.
You mentioned Areti, and I always smile when I hear this, this DSO, this Italian DSO name, because it's the same as mine. Actually, during Enlit, which will be in Bilbao, 18 to 20 of November, and INSIEME will be there at the EU Project Zone, I'm planning to go to Areti and ask them for a tote bag, because I really need to have one of their tote bags that says Areti on top. I want to pass a little bit to the concept of safety, because it's also very important, and it's one of the first things everybody thinks when discussing data spaces. Security and trust. Those are safety, right? Recurring themes. How does INSIEME ensure that energy data sharing is both secure and privacy respecting, while remaining efficient for market participants? And this is actually very, very crucial to combine those two elements.
Yes, I would differ a little bit between security and safety and trust, and like both are like highly interdependent, of course. With respect to security, I've referred to our identification and authentication strategy that we have developed in line also with European Commission's Data for Energy Expert Group and under the Smart Energy Expert Group, an action that has been started a year ago and is paving the way for a lot of crucial regulatory and legislative steps. There, it's very important that we make use of the eIDAS regulation. It comprises electronic IDs, trust services for certification, and time synchronization, and much more. Personal European identity wallets and business European identity wallets. And this is identification. Authentication is a thing that we shouldn't do for energy alone, because we have a necessity to also connect with a financial data space, with mobility data space. And if we don't get to a common identification system between the different sectors, but also within the sector, it's going to be very costly, very hard, and at the end also very insecure to run such a system, because there's inevitably going to be a lot of media breaks and broken chains of trust. So as one example where eID can help is like what we saw in our projects in the last years. Service providers are onboarding to Austrian market communication to provide a simple app to consult people on energy efficiency or their electricity consumption, right? So they do well, and then they want to go to a different member state, and just because of the need for DSOs, TSOs in that other member state to identify that service provider, they need to found a company, which costs them and a lot of ongoing costs, which is a big blocker for these new solution providers. And what you can do with eID is that you register in that market, you get the same electronic ID. It's a verified ID that is linked to your national company register, so the Austrian company register in this case. If I'm an Austrian service provider wanting to be active in a Danish market, it would show you that I am active and I'm representing my company as a managing director, or if I'm registering an energy community in Austria as an association, it would show that I'm entitled to act on behalf of this association. So it does a lot already. And these situations are not just specific to what we need in energy. And even more, it's like this requirement to create a legal entity each and everywhere contradicts the European concept of a digital single market. In the European Strategy for Data by 2020, that it was coined 2020, they already identified this means for a European identification authentication system as one of the pillars in the digital single market. And what we are trying to do with EDI and in INSIEME is to walk the talk, to just use what's there. And this is about security. Then trust. What we are following, providing as reference implementations is a common consent mechanism, a generic consent mechanism that allows people to do certain actions in a participative system under their consent, accepting a data sharing request, accepting that they are being assigned to a service provider, accepting or rejecting that they are being assigned to a community. This is a thing where we provide a common reference architecture. And lastly, because I referred to safety as well, the safety viewpoint in terms of system safety, what happens if something fails, how do we protect our systems, is also a viewpoint that we are putting forward. That is a viewpoint that is highly underrepresented in many initiatives at the moment. One very placative example is this strategy for our flexible connection agreement implementation. You need to have a fallback value, a default connection limit when communication fails. And that's just one very simple example. So very often the safety viewpoint is a bit underrepresented. And that's what we're trying to change, at least to a degree, in INSIEME.
Absolutely. It's one of the most important topics, and it's one that will make or break the European Commission's efforts with this. It has that potential. Now, if we look beyond Europe, for example, how do you see other countries like the United States approaching energy data governance and interoperability? And are there similarities, or are they completely different than what we're doing here in Europe?
There's similarities, but there's very important differences. First of all, we had some joint actions under the umbrella of Project EDI, where we extended a European write once, run anywhere layer for data-driven applications also to the States. So we supported a green button there, and we also the green button methodology and a new technology that is upcoming called the Linux for Energy carbon data specification, where utilities can just announce that they support the data sharing infrastructure, and then you can automatically add them into your data space. A very interesting concept, but one that is also pretty much tied to the necessities of the American market. Nevertheless, we can learn a lot from them. What we do also see is that some frameworks emerge in the United States, then they try to extend to Europe, but it's very hard to make them fit to European necessities. For example, standards that deal with controlling DERs, standards that deal with flexibilizing connections. Here, the structures and the market structure in Europe is very different from what you see in the States, and also the design goals. One very important thought that we took from our activities with the American partners is that the allowance for end-to-end encryption was a necessity for some American companies. So what we all enjoy when we write messages, our cell phone on direct messaging services, they are being device level encrypted to ensure that no man in the middle can read the data that is being transferred. And this is thoughts and solutions that we should adopt more in the electricity sphere. This is a thing that we can't fully solve at the data space level. We can provide reference solutions, but here things like that, concepts like that, features like that need to be supported by all participating platforms and solutions.
Exactly. And we can learn from other sectors, like, for example, the telecommunications, like you just mentioned. It makes total sense. Is there any particular thing, for lack of better word, in the EU model that makes it unique or potentially even exportable in the global context? What would you say?
My personal impression now is that we complain a lot about our highly regulated environment. What my impression from the latest exchanges is that it can also be understood as a guidance. So penetration of rules and also the acceptance of rules and the implementation of rules, even though it can be much better in Europe and it must become much better to allow for these digital business models, because otherwise you can't rely on the infrastructure that you would need to run the one or the other business model. We are in a much better situation from what we saw in the States. It's more like unregulated, very hard for service providers or these new solution providers to actually get what they need to be up and running and to get to service levels that would allow them to run good solutions. Here, I think there's a reason for why much more solutions are evolving in Europe at the moment than in the States. But that's my personal impression. And
absolutely, that's what I asked. I asked your personal impression. I wanted to ask you, as INSIEME progresses, I know it's a young project. It's only 7 months old. However, it steps upon INTNET, which was a much longer and a big project also. What milestones should we look forward to in the coming years?
Yeah, in the beginning, we are now inevitably still in the stage to shape the initial scope of the Common European Energy Data Space. It's a very complex field, but we are now in a very good position to finalize this and make it very much tangible and understandable. So please expect in the next 1 or 2 months good and understandable slides and concepts that will show you what we are up to. In Q1 next year, we will deploy our first solutions. We are also heading for making both the EDI framework and INSIEME open source and freely accessible to a wider community. So we are inviting everyone to review what we are doing and also contribute to these solutions. In both projects, we have a lot of requests and a thriving community already for people that are extending these things, and we are trying to increase the momentum for community building a lot. We are, as I've said, cooperating a lot with Data for Energy, which will pave the way on and give recommendations to the Commission for legal and regulatory activities. We need this regulatory guidance for the next step in INSIEME. And the reason for why this is so important is that we see a big role for especially for the energy data space, we foresee a big role for the regulated domain, so for system operators. And with all the conceptual work that we are doing at the moment, we are very focused on drawing a good line and a good interface between the regulated domain and the competitive domain. And in cooperation with all the stakeholders and the European Commission, there needs to be a clear statement of what needs to be done by that regulated domain, because only then you can begin to transition activities into an operational entity. And this is, I would say, the major milestone, because then you can work towards operationalization of the construct as a whole. It will take a lot of work on the legislative end. There will be costs, especially in the beginning, and there will be risks. And we are very much looking forward to work together with our friends from within the project and also from the project environment and the Commission to sort out these questions.
Excellent. We are at the end of our discussion, and I always like to close with a message for our listeners, or for the Commission, or for someone in particular. This time is in general for our listeners, about the importance of collaboration in building Europe's energy data infrastructure. What would your message be?
What we saw in the last years and the experiences that we made in the last years is that it's very important to give people a convergence target. We are doing so many things in Europe, and we are expecting people to comply with the regulation, with the goals that are being set on the European level. But we don't hardwire our expectations into code, into a reference application. And as I've got a technical computer science background, I need to give you one example from computer science. Back in 1995, the programming language Java was created. Before that, each and every software developer had to write its software, compile it, design it for different platforms, different hardware separately, which cost a lot of money. With that emergence of Java, and their mantra was write once, run anywhere. So they wanted to allow people to write their solutions once and deploy it across different hardware setups and different systems. They wanted to overcome this, which was a big promise. And in the beginning, what they had achieved was not a write once, run anywhere. It was actually a write once, debug everywhere. And but over time, hardware systems were designed for this convergence layer, for this interoperability layer. And that didn't just have a horizontal effect, but also a vertical effect, meaning that systems were developed with interoperability in mind. And we see a similar effect when we put in place our reference implementations, when national data sharing infrastructures are trying to integrate and improve their integrations with what we do in EDI and with what we're also going to be doing in INSIEME. So one key message would be that we should probably also learn to see this common European energy data space as a convergence layer and a North Star for digital infrastructures to orient it towards.
Excellent. Thank you very much, Georg. So thank you very much for this very interesting discussion. And I'm looking forward to meeting you, to seeing you again at Enlit.
Also here, looking forward to discussing with you and discussing with all the other people that we will meet again in Bilbao.
You've been listening to the EU Energy Projects podcast, a podcast brought to you by Enlit and Friends. You can find us on Spotify, Apple, and the Enlit World website. Just hit subscribe, and you can access our other episodes too. I'm Areti Ntaradimou. Thank you for joining us.